All right, this is Chapter 15, Part 2. And it's the manually regulated IVs. They're also known as the gravity flow. You'll still be asked for a flow rate with these, but your flow rates won't be in milliliters per hour. It'll be calculated in drops per minute. So these IV flow rates are calculated in drops per minute. The abbreviation is GTT over MIN. GTT is the abbreviation for the Latin word meaning drops. And I used to know what it is. I don't know what it is anymore. So when you're asked for the flow rate, it's going to be given, again, in drops per minute, but we want whole numbers, whole drops. I mean, if we were counting, how would you count 1/3 of a drop or half of a drop? Because when a drop falls, it's a whole drop. You can't do partial drops. You know, think about if you got a drip in your faucet or drip in your bathtub, you know, they fall in whole drops. Or if you're taking drops out of a dropper, they're small, whole drops. So we use the IV tubing, and you get several different sizes in it, but the IV tubing calibration is the drop factor. And that determines how big or how small our drops are. Okay. We have macro drops, which are the larger drops. And our drop factors come in milliliters. They're drops per milliliter. So our drop factors for 10 drops per milliliter. So that means that it takes 10 drops to fill up 1 milliliter. We have a 15 drop per milliliter. So those are just a little bit smaller than the 10 drops because it takes 15 of those. But they're still pretty good sized drops. And then we have the 20 drop per milliliter. Okay, these are our large drops, our macro drops. Then we have our small drops, which are called our micro drops. And these are very small drops, and the calibration is 60 drops per milliliter. Okay, this can also be known as a primary IV set. All right, so let's look at example number 6. We have an order for D5W at 125 milliliters per hour. The infusion set is calibrated for a drop factor of 10 drops per milliliter. And we want to know what is the flow rate. Just calculate the flow rate in drops per minute. Okay, so out of all this, the flow rate, remember I told you, was your total volume over your total time in hours. All right, to get it in drops per minute, we've got to change our hours to minutes. That's the only, and we've got to do it times the drop factor, which is our drops per milliliter. Okay, so that's the only two things that we're doing differently here. But sometimes they give it to us as a rate. Our rate, the 125 milliliters over 1 hour, is still considered our total volume over our total time, because we're running 125 milliliters for every hour. Then I'm going to convert my 1 hour to 60 minutes. So I'm going to have eventually drops per minute. And then I multiply it by my drop factor. And in this case, my drop factor is 10 drops per milliliter. So this way my milliliters cancel, my hours cancel, and I'm left in drops per minute. And I can do my zeros cancel. So I'm going to have 125 over 6. It's going to be drops per minute. And we have to divide that out. And when I divide that out, I get 20.83. So we've got to round that to the whole number. Some people round it to just whatever whole number it is. Some people will round it up. I'm okay with either way. A lot of times it's going to depend on where you're working. To me, the 0.83 is real close to 21. So I'm going to round it to 21 drops per minute. Okay? If you give me 20 drops per minute, it's okay too. So either one is correct. Just however you want to round it. If we look at example 7, I have an order. It's ampicillin, 500 milligrams, IV in 100 milliliters of normal saline to infuse over 45 minutes. And again, I want the flow rate. It says to calculate the flow rate. Oh, it didn't give me a drop factor. I forgot to add that in. So we've got a drop factor of 20 drops per milliliter. So that's the drop factor I want you to use. So to calculate the flow rate, and the reason I know that I'm going to do it in drops per minute is that it gives me a drop factor. So anytime I have a drop factor, that means that my answer is drops per minute. Okay. Now, what do I need out of this doctor's order to calculate the flow rate? Do I need the 500 milligrams of ampicillin? That's not a volume, that's an amount of medicine. So I don't need the 500 milligrams. And it's IV in 100 milliliters. So this is in 100 milliliters. So that's my total volume. I need my time to infuse over 45 minutes. So this is my total time. And then my drop factor. So again, it's your total volume over your total time, or volume of IV fluid. And I'm going to put it like that. So you're going to total time in minutes this time because it's drop factor, times my drop factor, my drops per milliliter, and then times if I got to convert 1 hour to minutes, to 60 minutes. This one is optional because it depends on if we're in hours or if we're in minutes. So my total volume being 100 milliliters, my total time is 45 minutes. So this time I'm in minutes, so I don't have to use my conversion, my hour to minute conversion. I just have to multiply it by my drop factor, which is 20 drops per milliliter. So drop factor is per milliliter, answer is per minute. So my milliliters is going to cancel, and then I don't have any zeros I can cancel. So I'm going to multiply 100 times 20 and get 2,000. And then 45 times 1 is 45. When I divide that out, I get 44.4. So if I round that to the nearest whole, it's going to go to 44 drops per minute, because the 0.4 does not cause me to round up. Okay? It just leaves it the same. So it's 44 drops per minute. And that's your answer. Okay, so example 8. I have an order for normal saline IV 3,000 milliliters per 24 hours. The drop factor is 15 drops per milliliter. And I need again to calculate the flow rate. Since they gave me a drop factor, then my answer is going to be in drops per minute. And I should have been doing the X all the time. So this one is going to be drops per minute also. So then my total volume, which is my 3,000, my total time is the 24 hours, and then my drop factor. So I'm going to have 3,000 milliliters over 24 hours times my drop factor, the 15 drops per milliliter. And then since it's an hour, I've got to convert my 1 hour to 60 minutes. Now, if you convert your hour before you multiply times your drop factor, that's fine. Doesn't matter the order. It's whatever works for you. Okay, so my zeros, 1 0 will cancel. 6 will go into 350 times, because 6 times 30. 6 times 5 is 30. So 6 times 50 is 300. So then I have 50 times 15 over 24. My calculator out. 50 times 15 divided by 24. So actually it would be 750 over 24 will give me 31.25. So when I round that to the nearest whole number, I'm rounding it to 31 drops per minute. Okay? So questions. I wish I could answer them. Wish we were in class where I could answer them. So we're going to look at a couple more of these. We're going to look at number 11. 9 and 10 are similar to what we've been doing. So we're going to look at example 11. And example 11 is that I have an order for D5 1/2 normal saline with 20 milliequivalents of potassium chloride. K is potassium, Cl is chloride, per liter to run at 25 milliliters per hour. I wrote 5 there, per hour. You have a drop factor of 60 drops per milliliter. And again, it wants to know the flow rate. Okay, and I'm showing you this one because it's got a few numbers that we really don't need. Again, the 20 milliliter or the 20 milliequivalents of sodium chloride is just the amount of sodium chloride or potassium chloride that's in the bag. So we don't need that number. Per liter, well, that's the volume of the IV bag, but when it gives me a rate, I don't have to have the per liter. So if it didn't give me a rate and gave me per liter to run over so many hours, then I would use my liter per hour. And then I need my drop factor. So to find my flow rate, it gave me a drop factor. I'm going to use drops per minute as my answer. So the 25 milliliters per hour is my total volume over total time, times my drop factor, 60 drops per milliliter, and then since it's an hour, 1 hour, 60 minutes. Okay. Well, if you'll notice, I got a 60 on bottom and a 60 on top, so those just cancel. My hours cancel, my milliliters cancel. So now I'm left with drops per minute. So I have 25 drops per minute because this was 1 and this is 1. Okay, so you've got to be careful and choose the appropriate numbers in order to get the right answer, because your orders are going to give you a lot of information that you need as nurses, but not always the information you need to count the or to calculate the flow rate. All right. So number 12, I have an order of packed red blood cells. Sounds like the person may be getting a transfusion. 480 milliliters IV to infuse in 4 hours. My drop factor is 10 drops per milliliter. And again, I want to know the flow rate. Since I've got a drop factor, it's drops per minute. So I'm going to start. I've got 480 milliliters in 4 hours. That's the only two numbers, and those are the two numbers I need. Total volume, total time. So I'm going to have 480 milliliters over 4 hours. Then times my drop factor, 10 drops per milliliter. Since it's in hours, I've got to do my time conversion. 1 hour, 60 minutes. I know 10 goes into 10 once, 10 will go into 66 times. My milliliters cancel, my hours cancel. So when all is said and done, I've got 480 divided by 4 times 6, which would be 480 divided by 24. And I get exactly 20. So my answer is going to be 20 drops per minute. Okay. Now again, I wish I could sit here and answer your questions. Come back in a few minutes with the shortcut method. So it'll be part 3 of our video series on chapter 15.